In this section, we're going to discuss a case study finding points or pairs on an XY plane. The problem itself is somewhat instructive and interesting, but what I found upon reviewing it was something even more interesting, at least to me. The idea is that one programmer can write a solution to a problem and even test to make sure it's correct, only to miss some very obvious problems. I have looked over the code and believe I have at least 3 categories of problems discovered, and it's not insult to the author, it's simply reviewers didn't help him out too much here. First correction is initialization inefficiency. We have here the point 0 and point 1 being compared to initialize the shortest distance, then in a loop they're compared again. This duplication of effort, although the cost is small, the problem is suggestive of one of misunderstanding. If the computation were expensive, this being done twice would cost us a lot of unnecessary effort. Initializing variables is a tricky issue that takes some consideration. Don't just slap a 0 in or something else and then assume you're finished. In this case, what we should do is assign the shortest distance variable to some value such that any computed distance would be less than that and allow the loop to do those determinations. In this case, double.maxValue is the highest representable number. In the section on wrappers, this is discussed further, but every data type has a class. Notice the class is uppercase D for double, with a maximum value, minimum value, and potentially other constants to help use the data type well. Since we're looking for a small value, we should initialize the variable initially to the maximum representable value so that every distance will be less than or equal to that. The comparisons will work properly. The second correction is loop bounds. The nested loops are nearly correct. The outer loop has a wrong maximum value. The code always compares a pair of points. The outer loop represents the leftmost point of the comparison. The inner loop is going to pick the point in the array next to it. So outer loop index, whatever that value is, +1, all the way to the end of the array on the right side. The maximum index for the inner loop is the maximum index of the array, but for the outer loop, it should be the maximum index of the array -1, or the length -2. The inner loop will fail when the miscoded outer loop hits that point of being too large, simply because the inner loop continuation test will not succeed. So the code works correctly, but it's not coded correctly. And I would prefer you to look at that and realize that coding must be as precise as possible. Don't allow the inner loop failing to run one iteration to be a good way of bounding your loops. Rather, determine well what the index values must be and pick that set carefully, making sure you're always in bounds. The third correction is comparison order. This is not a bug, it reads awkwardly. The nested loops are trying to discover the shortest distance. After a pair of points is tested, this distance needs to be checked to see if it's less than the current shortest distance. That's the way our mind is reading this problem. Is this new distance less than the old shortest distance? If so, we update the shortest distance with the newly discovered shorter distance. But the test reads exactly the opposite. It says if shortest distance is greater than distance, that just jars the mind. What are we comparing greater than for? Better is to say if distance, which is the newly computed distance, less than shortest distance, then assign shortest distance to the current distance. That flows more correctly with our mental picture of what we're trying to do. So again, as long as it's coded correctly, it does not matter. But when readability is involved, it does matter quite a lot.